Hi everyone, and welcome to this lecture on Chapter 1, Part 2. So again, hopefully everything is working with the video quality, the sound quality, and being able to see both the PowerPoint slide and my little icon image. If you have any issues with the presentations, with any of the lecture recordings, please email me right away. Alrighty, so in part 2 of chapter 1, we're just going to pick back up where we left off. So we had just finished reviewing the different nutrients. So now we're going to talk about all the nutrients from a new perspective. So talking about them less from like the chemical, biological perspective, and now talk about them more from the sort of social science perspective. So how much of the different nutrients do we need or should we consume in order to achieve that concept of health or wellness or thriving? So in order to talk about how much we need, that information has been roughly collected by experts in science and various aspects of science and nutrition and medicine really over the last, say, 100 years or more. And so over those last several decades, that information has been compiled into guidelines that suggest how much a person should eat to maintain their health. So those guidelines, we're going to talk about two different guidelines. This chapter, we're going to talk about one of them, and then in chapter 2, we're going to talk about another set of guidelines. So the guidelines we're going to talk about in this chapter are called the Dietary, are called the Dietary Reference, called the Dietary Reference Intake Values, or the DRIs, Dietary Reference Intakes. Definitely need to know this for better or worse. This is a major aspect of the nutrition field. So not only do you need to know this for our tests, but you will also utilize this in the project that I've assigned for the course, the My Diet Analysis project. And if you go on in the field of nutrition or in the field of public health nutrition, knowing this information will be a key component of your job, knowing and utilizing this information. So the Dietary Reference Intake Values are written by a group of experts called the National Academies of Sciences. The full name is the National Academies of Sciences, Engineering, and Math. They were formerly called the Institute of Medicine. So sometimes you might hear Institute of Medicine referring to the same group of experts. So the Dietary Reference Intake Values are written by the National Academies of Sciences, and they are a set of standards that define recommended intake values for various nutrients. So they are basically the recommended daily intake amounts or recommended intake values for our different nutrients. And pretty much all of the nutrients that we'll learn about in this class have recommended intake values. So, okay, so that's great. So that helps us understand how much of the different nutrients we need. And then, as I said, for anyone who goes on to work in the field of nutrition or even public health nutrition, this information would enable a person to plan out healthful diets or healthful ways of eating for individuals and for groups. So it helps us understand how much we should eat, but then it can also help to inform policy, like we talked about previously, and it can also help to inform like social environments, right? It's having access to these different types of health promoting foods and the nutrients that they contain. The Dietary Reference Intake Values are based on disease prevention and risk reduction for chronic disease. They can be used to promote optimal health, but really they're based on disease prevention. Some of the nutrients also will have not just a recommended intake level, but they will also have a recommended do not exceed level, so an upper level for some nutrients, not all. you might think about, we in part 1 of chapter 1 lecture, we talked about water-soluble and fat-soluble vitamins, and that one of those categories makes it much easier to achieve toxicity, right, of that nutrient. Was it water-soluble or fat-soluble? You might recall that it was the fat-soluble vitamins because we can store them. That means we can accumulate levels of those vitamins like too high. And so there are upper level intake values suggested for example, some of our water-soluble vitamins. So these standards are, again, aimed at disease prevention, or I shouldn't, aimed at, maybe isn't the best way to say that, but based on the information that was collected and the information on which these values are based on information from healthy people. So these standards apply most well to healthy people. So these are dietary standards for healthy people. These reference values do not apply very well to people with a disease state or to someone who's suffering from a nutrient deficiency. In that case, if someone, so again, let's talk about the ariboflavinosis, the vitamin B2 deficiency. If someone is deficient in B2, then simply meeting the standard for disease prevention for vitamin B2 won't be enough to help move that person out of a state of deficiency, right? Similarly, someone who's dealing with chronic disease, heart disease or diabetes or obesity, many of the nutrients will have differing recommended intake values based on that disease state. But those differing values aren't established like the dietary reference intake values are. That's for a trained professional, again, a dietitian or a nutritionist, to assess the disease state, assess and understand the recommended intake values for disease prevention, and then make an expert recommendation based on those sources of information for that particular person. So this is an important piece to note, and this is usually winds up being a test question somewhere, is that the dietary reference intake values are based on information about healthy people. So these guidelines are really meant to say, okay, this person's already in pretty good health, here's how to maintain that health, right? And then certainly we can extrapolate that. Again, a nutrition professional can extrapolate that information to say, okay, this person's in a disease state. Based on the guidelines for healthy people, I'm going to tweak those a little bit and make these recommendations to that person to pull them out of the disease state. All right, this is kind of the mother lode here. Definitely need to know this slide really well. There are 6 different dietary reference intake values that you need to be familiar with for this class. So those 6 values, we can put them into 2 categories. So there are dietary reference intake values for most nutrients, and then there are dietary reference intake values specific for energy. So maybe I could have put this bottom one first because this is how my brain organizes it. I remember that these 2, the acceptable macronutrient distribution range, which we fondly will call the AMDR, and the estimated energy requirement, which we will conveniently call EER, are specific to energy only. So remember, what does energy mean? Energy is synonymous with calorie, right, or fuel, but in this case, let's say calorie. So here's the next step for that would be really key for you to think about here. What are the nutrients that are related? Well, I'll say specifically that supply or provide energy. What were the 3 nutrients that provide energy? Right? Carbohydrate, I'll say carb, protein, and fat, right? Or lipid, right? So when we say these are for energy, I could say for the energy nutrients. Or I could simply say for the macronutrients, right? The dietary reference intake values for the macronutrients. So AMDR will only ever apply to carbohydrate, protein, and fat. EER, similarly, will also only be used in reference to carbohydrate, protein, and fat. EER we'll see is actually specific only to calorie. AMDR is talking basically calories from carbohydrate, protein, and fat. So you can kind of categorize those two away. Simple. AMDR, EER, we're talking about calories. We're talking about the macronutrients. The rest of these, let me go to highlighter and just change my color. The dietary reference intake values that are for other nutrients, these will also, for most nutrients, so the macronutrients will be included here, but there are 4 subcategories here. So we have the estimated average requirement, or the EAR. We have the recommended dietary allowance, or the RDA. We have the adequate intake, or the AI. We have the tolerable upper intake level, or the UL. There are 2 here, really it's the RDA and the upper level intake that you will need to be most familiar with for this class. And also, if you were to go on in the field of nutrition, it would be these 2 and these 2 that you would need to know the most well. All right, let's go through each one in a bit of detail. So estimated average requirement, by definition, this is the average daily intake level of a nutrient that is required to meet the need of 50% of the healthy people in a particular life stage or of a particular sex. Estimated average requirement, look how vague that is. Estimated average requirement. So it's meant to meet the needs of half of the people in a given population or life stage or sex. It is used to define the RDA, which is the next one. So the RDA is the average daily nutrient intake level that meets the needs of most of the people who are healthy in a particular life stage or sex group. So this is the recommended dietary allowance. I sometimes say daily because the RDA, as you'll see, is referring to a daily intake level on average, or as you'll see and as it's written right here, right? It's on average, this is how much of a nutrient a person should consume in a day to maintain their health. It is important to note that RDA is referring to the majority of a population, a majority of the healthy people in a population. So 97 to 98% of the people in this group, in this life stage or sex, would be healthy and maintain their health if they followed this daily intake level, which is the RDA. Adequate intake, so adequate intake in EAR we don't use so much. EAR we don't use so much because it's only meeting the needs of half the people. So, okay, that's not gonna help us too much. EAR is really only useful because it informs the RDA. In some cases, we'll see we only have enough information. So we only have enough information to make it to an EAR, and there hasn't been enough new information to get us all the way to an RDA. So the EAR is kind of like a step to the RDA. Adequate intake is similar to EAR in that adequate intake is used when there is no RDA available. So EAR kind of gets us so far, gets us like a baseline. If we have more information, we can make an RDA. If we don't have enough more information, we'll make this adequate intake recommendation. So it's a recommended average daily nutrient intake level based on observed and experimentally determined estimates that would meet the needs of a healthy group of people, right? Or a group of healthy people. So adequate intake is still sort of saying we know something about this nutrient, but we really don't know enough to make a solid recommendation about how much you should have. So this is just saying if you have this much, that should be enough, but more is probably better, but we don't have that information to say clearly just yet. So some examples here of nutrients that have an AI and not an RDA is vitamin K, chromium, fluoride, and some of the fats. We're going to talk about, you might remember I said that lipids is like a group of lots of different types of molecules. So some of the fats, we have enough information to make an adequate intake recommendation, but not so much information that we could really make an RDA. So again, this is really just based on the fact that nutrition as a science is still quite young, and we've really only begun to study and even to identify some of the nutrients that we talk about when we talk about nutrition. So hopefully at some point these different nutrients will have an RDA, but so far the research is just relatively limited, so we can't really make an RDA for some of these nutrients. Alrighty, and then the tolerable upper intake level, I said, is another one to highlight, another one we use often. So tolerable upper intake level, it's abbreviated UL, so upper level, because that's what it's implying, right? So this is the highest average daily intake for a nutrient that would likely pose no risk of adverse health effects to most people, right? Likely cause no adverse health effects. So sodium is a classic example here. We know that too much sodium is problematic for just about everybody. So the tolerable upper intake level for sodium is 2,300 milligrams per day for someone who's following a 2,000 calorie diet. So what that means is that for most people, they can eat 2,300 milligrams of sodium a day and have no adverse health effect, no adverse health consequence because of that. But that's most, not all people. Some people have underlying, like, call it a sodium sensitivity, right? Or underlying, they have a propensity towards a higher blood pressure. And sodium, we'll learn about, is one of the nutrients that affects blood pressure very directly. So for those people, there would be health consequence consuming sodium at 2,300 milligrams per day. So for anyone who has propensity for high blood pressure, the recommendation for sodium is 1,500 milligrams per day. That's almost 1,000 milligrams less, because we know that as that person approaches this upper intake level, adverse health consequences are likely. So consumption of a nutrient above the upper limit increases the potential risk for toxic side effects and health risks. We do not have a UL for all nutrients. And again, that's just because for some, there may not need to be an upper level, right? But largely, we don't have an upper level for every nutrient because we haven't done enough research on all the different nutrients in order to understand what a realistic tolerable upper intake level would be. Okay, so here is a nice little chart from your book, or kind of an image from your book, just showing these for dietary reference intake values. So you have the EAR, right? That's going to meet the need of 50% of the individuals in a given population. The RDA, right? This is kind of the ticket, right? This is what we're going for, is trying to have at least this much. Yep, so at this level, we would meet the needs of just about almost the entire population, right? 97, 98% of the population. And then tolerable upper intake level, this is where we start to see increased risk. Above that level, we see increased risk of toxic effect. And you'll see adequate intake isn't quite on the chart. That's again just because it's used only when an RDA is not established. So it's sort of like the, if you ever like play Sudoku or do a crossword puzzle and you sort of like pencil in your answer until you're sure of it, that's kind of what the adequate intake is. It's like penciling in the RDA until we're sure and can confidently call it an RDA. Alrighty, so now we'll talk about the two remaining dietary reference intake values that are specific to calories. So let's talk first about estimated energy requirement, or the EER. So estimated energy requirement, a week from now or 2 weeks from now, or when you're preparing for the Unit 1 exam or the final exam and you forget what estimated energy requirement is, literally just look at the name. Estimated energy requirement, right? You could probably tell me the definition, or tell your friend in class the definition of estimated energy requirement just by thinking a little bit about what that title implies. So it's the estimated amount of calories, right? Energy synonymous with calories. The estimated amount of calories required per day, right? These are all talking about per day. It doesn't say that explicitly, but that's what it means. So it's an estimation of the total number of calories required per day. Remember that calories only come from carbohydrates, lipids, and proteins. Yes, calories can come from alcohol, but we're talking about nutrient needs here. So really any calories that come from alcohol, we can say will always be in excess of what we need, because we never need alcohol. So this is the average daily energy intake that is required to maintain energy balance. We're going to actually revisit energy balance all the way at the end of this class, like in Unit 4. Energy balance is just really simply, it's talking about balancing the amount of energy or calories that come into the body. And the only way we get calories in is through food or drink. So balancing calories in with calories out, meaning the calories that the body expends or uses. And we expend calories by maintaining basic life, right? So breathing, having our heart beat, having our liver and our kidneys and our brains work. We expend energy by digesting food. We expend energy by physical activity. So energy balance means that the calories that come in through food and drink are equal in number to the amount of calories that we expend through physical activity, digesting our food, and maintaining our basic existence. In a healthy adult. So if someone is trying to lose weight or gain weight, we can use the estimated energy requirement to figure out, okay, how many calories does that person need to maintain their weight? And then we can do a simple calculation to say, okay, if they want to lose weight, we would obviously want to encourage them to eat fewer calories than that per day. If they want to gain weight, we would want to tell them to increase the calories above that per day. Estimated energy requirement is defined, and this is also key, is defined by these 5 things. How old a person is, their sex, so whether they're male or female, their weight, their height, and the amount of physical activity that they do. So estimated energy requirement is very specific to an individual. These 4 requirements are not specific at all, right? The RDA meets the needs for nearly everyone. That couldn't be more generalized. These 4 right here are very generalized recommendations. These 2, the EER and the AMDR, are very specific to an individual. Well, especially EER. Actually, let me say only EER. Forget that I went to the AMDR slide. EER is very specific to an individual. We can and will each calculate our own estimated energy requirement. Then the 6th of these dietary reference intake values is the acceptable macronutrient distribution range. So the acceptable macronutrient distribution range, again, if you a couple weeks from now when you're reviewing and you're like, what the heck, did we even learn about that? Look at the title, right? So acceptable, okay, so it's an acceptable distribution of the macronutrients. an acceptable distribution of the macronutrients. What is a distribution, right? It's kind of like how much of each one, right? How much of each one? So acceptable macronutrient distribution range is the suggestion of energy intake from each of the different macronutrients. And this would provide adequate intakes of essential nutrients while reducing the risk of chronic disease. Nutrient intake outside of these ranges, so above or below these ranges, has the potential to increase our risk for poor health. And we'll see that these ranges are defined as a percentage of total calories. So take a minute, pause if you want to, just review these three phrases right here because they're very important in understanding acceptable macronutrient distribution range. So AMDR is also generalized to the entire population, but it can be tweaked to meet an individual's needs. So here is what the AMDR values. So the acceptable macronutrient distribution range suggests that for all of the calories that we take in a day, and again, calories are only coming from carbohydrate, fat, and protein, of all the calories we take in a day, 45 to 65% of those calories should be provided by carbohydrates. In other words, of all the calories we eat, the majority of those calories should be in carbohydrates. 20 to 35% of our total daily calories should come from fat, and 10 to 35% of our total daily calories should come from protein. So these are the two DRIs related to energy, AMDR and EER. EER is very specific to the total number of calories that we would consume in a day. And then AMDR helps us understand, okay, based on that total number of calories, let's say 60% of them will come from carbohydrate, let's say 20% of them will come from fat, and let's say 20% will come from protein. So when we see this down here, percentage of total energy intake is EER. So once we determine EER, that's going to be a number of calories, right? Let's use the classic 2,000 calories a day, right? Usually it's not 2,000 though. When you actually calculate it out, a lot of people will be, maybe they need 1,800 calories a day, or maybe they need 2,200 calories a day. But if we have 2,000 calories that we need to eat every day, again, I'm going to choose numbers within these ranges. So I'm just going to choose 60%, 20%, and 20%. This is what I mean by AMDR is generalized to the specific population, but generalized to the entire population. Within those recommendations, though, within these ranges, a nutrition professional can advise a person, based on your physical activity level, based on your lifestyle, based on your dietary interests, I suggest you try to meet these percentages. So if 60% of 2,000, right, because these are percentages, so if 60% of 2,000 is coming from carbohydrate, which I'll abbreviate CHO, what's 60% of 2,000? If you're good at math, you don't need a calculator, I guess, like I do, right? It's 1,200 calories. So this is saying that 1,200 calories should come from carbohydrate. How about the fat up there? Fat is 20%, right? So what's 20% of 200? That's 400 calories. And protein is the same, 20%, right? And again, you can organize any numbers that you want here. So another 400 calories, right? And then if we add those all back up, 400 plus 400 is 800, 800 plus 1,200 is 2,000. They should add back up to the total EER, right? This is EER. And this down here is AMDR. And then utilizing what we learned about in the first part of this chapter, how many calories per gram, we can actually then figure out the number of grams of each of these food that we need per day, right? So remember, carbohydrate had 4 calories per gram, right? So if we divide 1,200 calories, if we divide that by 4 calories per gram, that's going to give us 300 grams. So we would need 300 grams of carbohydrate per day. I'm sorry, I don't know why it makes those lines. Fat, remember, fat was the most energy dense. Fat had 9 calories per gram, or fat provides 9 calories per gram. So if we divide 400 by 9, that gives us about, what, 44? So we need, from fat, we need 44 grams per day. And protein, again, was another 4 calories per gram. So if we divide 400 by 4, we get 100 grams for the protein. I know this is a hot mess. I have this also written out. I think I have this also written out, and I will post it to Blackboard so that you can take a look at it in text, so it's not as jumbled as my mouse writing here. But this is, being able to make these calculations is paramount to passing this class, to understanding this class, at least to passing the Unit 1 exam and probably the final exam. If you don't understand this, if you don't understand how to make these calculations, review your textbook, review the example that I put on Blackboard, email me, right? I am working remotely this semester, but I can, and this is obviously an asynchronous distance learning class, but I can certainly meet you for office hours virtually. I can pretty much facilitate any day of the week, but we need to schedule it because I'm not holding consistent office hours just because of the distance learning this semester. So if you would like to meet to chat about this or anything, please just send me an email and we can set up a time to meet virtually or over the phone. Okay, so this is just putting this all again together to review. And I highlighted the 4 that you really need to understand. So these are the 6 different dietary reference intake values. All right. Next, we're talking about how to assess nutritional status. So a lot of this information we'll revisit as we go throughout the semester, but we'll kind of introduce the concept here because again, if you choose to, or when a person does continue on in the field of nutrition, whether they become a dietitian or a nutritionist, this is a major part of the profession, is being able to assess a person's nutritional health. This is also what your My Diet Analysis project is all about, is assessing your own nutrition status based on a few tools that you can use at home, and then using what you learn in this class to kind of analyze your nutritional health and make recommendations to yourself. So a nutrition professional would go through various, would utilize various tools to assess and understand a person's current nutritional status. So familiarize yourself with this concept of nutritional status, right? This just means their current health, their current state of health, their current status, so their current nutritional state of health. So we can look at, in a nutrition assessment, we can look at a person's weight, we can look at their ratio of lean body mass to their fat mass, and we can also assess their energy and nutrient intake, which is what you are going to do in the My Diet Analysis project. Okay, so there's a kind of a 4-step plan in the nutrition care process. There's the assessment, which again, these are some parts of the assessment. There can be more. Then there's diagnosing, so whether it's arriboflavinosis or it's osteoporosis or some other nutrient deficiency or excess. the nutrition care professional or the nutrition professional can make a diagnosis or support a diagnosis that might come from another health professional, primary care, for example. Then we would prescribe and write a nutrition intervention. So what to do going forward to improve the person's nutritional health. And then we would definitely want to see ongoing monitoring and evaluation to make sure that the intervention that we wrote for this person is actually having the intended effect. So monitoring and evaluation, that might look like the patient is self-monitoring whatever the specific changes are, and then you meet, every other week or monthly to evaluate and see how things are going and make changes as necessary. So that's kind of the 4 steps, really similar to any other healthcare profession where you would assess what's going on, make a diagnosis, write an intervention, and then monitor and evaluate ongoing. Okay, so let's look at the domains of the nutrition assessment. We're going to go through, we aren't going to go through in much detail the diagnosis, the intervention, the monitoring and evaluation, but we are going to spend these next several slides looking at the various components of nutrition assessment. Because again, many of these you can do right from home now, and you're going to utilize these in the My Diet Analysis project. So there are 5 domains of the nutrition assessment. There is food and nutrition history. There are anthropometric measurements, which are like physical measurements, basically, of the body. And then there's biochemical data, which is sort of like medical tests, your labs from your blood work, and potentially procedures. And then there are physical findings. So again, the chelosis is actually an example of a physical finding. Noticing what's going on with the person's hair, their fingernails, their skin around the lips, the tongue, the eyes. All of these things are physical findings that often have a nutrition, they're related to nutrition. And then any other health history, so history of disease or illness, potentially history of surgeries, all of these things. So again, if a person goes to meet with a nutrition professional, the nutrition professional would collect all of this information from the patient so as to be able to assess what is going on with this person and attempt to make the best diagnosis that they can, which would then inform the intervention and the monitoring and evaluation. Okay, so now we'll go through each of these 5 in a little more detail. So food and nutrition history, this is very subjective data. This is not objective. It's subject to the person and subject to their interpretation of it. So there are different ways that we can collect food and nutrition history. One is just a diet history, where you just sort of ask them, what do you typically eat? Just tell me what you typically eat. Not very specific, right? And again, subject to the person's memory and their willingness to accurately self-report. You could have them do a 24-hour diet recall. So rather than just saying, what do you typically eat? See if they can tell you everything they ate from noon yesterday to noon today. Again, subject to their memory and their willingness to report. You could have them fill out a food frequency questionnaire, which is sort of like a multiple choice questionnaire where they answer a lot of questions and a lot of detail about how often they eat different types of foods. Again, subject to their willingness to self-report accurately. None of this can be empirically verified, right? So none of it can be scientifically proven. That's what it means to be subjective. And then you could have them do a diet diary or a diet record or a food record or food log. There's so many different ways to say this. This is what I have you guys do for My Diet Analysis, is keep a food, beverage, and exercise diary or a food log. I call it a food log. So you don't have to have them do all 4 of these things by any means, but usually one of these methods would be utilized to assess their nutrition history. I have an example of a food frequency questionnaire listed in this week's content. You don't have to do anything with it, but if you're curious to see what a food frequency questionnaire is, just open that up and take a look at it. Okay, second was anthropometric measurements, right? So these are common physical measurements that we can do. And again, many people can do these at home, but best is if the trained professional does them, because again, they're going to know the exact place to make these measurements. And for subsequent follow-ups and evaluations, ideally that same trained professional can do the same measurement. So your margin for error is greatly reduced. You can have people do this on their own at home, but again, then it's a little bit more subjective because it's sort of a self-measurement. You know, we can't see the backsides of our bodies, so we can't always see if a measuring tape is in the most appropriate place. So the common measurements are height, how tall you are, body weight, so stepping on a standard scale. You can do waist circumference and hip circumference. So waist, kind of the narrowest part of the abdomen, hip, usually the widest part of the hips and buttocks region. You can do limbs too, like the upper thigh, the upper arm. And then for infants, often we're looking at actually a head circumference because the growth of the head generally indicates healthy nutrition status and healthy growth. With the anthropometric measurements, then we're typically going to be comparing these to the standards for specific age or, sex group. Same over here, we would compare these to the dietary reference intake values. And then there are, so repeated measurements can assess trends in nutritional status or growth. Again, you would repeat the measurements ongoing as you're monitoring and evaluating the patient. The biochemical data and medical tests and nutrition-focused procedures. So again, blood analysis and urine analysis will help indicate potential nutrient deficiencies or potential nutrient excesses. Other medical tests could be pulse, blood pressure. Both are commonly used in assessing heart health, body temperature, respiratory rate, auscultation, so listening to the sounds of the heart and lungs. Again, making sure that they sound kind of, clear and healthy and not kind of congested or clogged. So again, these different sort of biochemical data can inform an understanding of the person's nutritional status at the time that they come in. These can also be performed ongoing in subsequent evaluations. And again, based on the nutrition plan that you write for them, you would hope that these things improve. And then nutrition-focused findings. So down here again, these are the common areas of our bodies that indicate nutrition status. Hair, skin, tongue, eyes, and fingernail can really provide quite a lot of information about nutrient status. These are objective data. They can be empirically verified. And of course, they're going to vary according to the disease symptoms, medical history, and risk factors. These are best done by the nutrition professional. Again, obviously a person can say, yeah, my nails are more brittle, or yeah, my nails have become more strong, or my hair is cracked and falling out, my skin is cracked, my eyes are really dry. So again, a client can provide this information to the nutrition professional, but best if the nutrition or some other healthcare professional is acquiring this information, like a nurse. And then a health history questionnaire. So so this is another really interesting and useful tool for a nutrition assessment. These can be pretty extensive and sometimes can be pretty, how do I want to say, they can really be asking a lot of information about the person as a whole person. Because again, like nutrition doesn't happen in a vacuum, I like to say, right? Nutrition, what we're eating, how we're eating is always influenced by so many other things. So again, someone who's trying to advise a person on their nutrition, the more complete picture they have of the person and their life and their lifestyle, the better that person is, the better that professional is going to be able to make realistic advice and suggestions to the patient that might actually work and be useful. So health history questionnaires are often looking at for history of health and illness, again, any history of surgical procedures, history of drug use, and history of diet and exercise. A lot of the information might be, what are the medications a person is taking and has taken, family history of disease, exercise history, some social and socioeconomic factors, so race or ethnic background, education level, marital status, sleep might even be asked about, mental health might even be asked about. What else here? Bowel movements might be asked about. Bowel movements. So all sorts of other information, other health-related information can be asked here. Again, just to allow the nutrition professional to look at the patient as a whole person affected by their environment. You might even ask about living environment and sense of safety and security in the living environment. So again, health history questionnaire can be very long and very thorough and very detailed. You can ask sometimes some really deep questions, but hopefully as you gather that information, you as a nutrition professional are much better equipped to sort of understand the person as a whole person and make more useful suggestions to them. So I'm going to toggle back to here. So this next little bit we're going to talk about is kind of how some diagnoses that a nutrition professional might make. So the really basic nutrition diagnoses we can make might be malnutrition, overnutrition, and undernutrition, right? We could make some other diagnoses too. Certainly from lab data, we might be able to see, okay, yes, this person is showing that they are hypotensive or hypertensive, or this person is showing their blood cholesterol profile indicates that they probably have hypercholesterolemia, or this person's fasting blood sugar and their hemoglobin A1C is indicating that this person has type 2 diabetes. But specific to nutrition, some of the diagnoses we could make might be malnutrition, overnutrition, and undernutrition. So what are these in definition? So malnutrition, again, with so many of the terms and concepts that we'll learn about in this class, if you forget what it is, just like decipher the word a little bit. So mal, right, like maladaptive or malfunctioning, right? Mal means like poor or wrong or off or bad maybe, right? So malnutrition means that the nutritional status of a person is out of balance. There's either too much or too little energy coming in over a period of time, or it could be too much or too little of a micronutrient. Overnutrition, again, overnutrition, more, too much maybe. This occurs when a person consumes too much energy or too much of a specific nutrient over time. So this is important too, is over time, right? Not like today, right? Like I ate too much pizza today, right? Or I consumed too much alcohol today, or I did mega dose on vitamin C today. That's not malnutrition, that's not overnutrition. That's like today you had too much. Malnutrition, overnutrition, and undernutrition are looking over time. Really, we're talking weeks or months in this case, and certainly years too, but a minimum of probably like 3 weeks to a month to be able to classify malnutrition or overnutrition. And then and same with undernutrition. So undernutrition just means the opposite of over, right? So it's too little energy or too little of a nutrient consumed over time. So this could lead to weight loss, nutrient deficiency, or a nutrient deficiency disease like osteoporosis. Whereas overnutrition can lead to overweight or obesity, or something like heart disease with too much sodium, or nutrient toxicity, like if we had too much of vitamin E, for example, or vitamin D, which are fat-soluble vitamins. And then we can, so if we identify nutrient deficiencies, we can further classify those. So let me go back here. If we have undernutrition, there might be nutrient deficiency, right? And nutrient deficiency, we can kind of identify it as either a primary deficiency or a secondary deficiency. And this is, primary and secondary deficiency is referring basically to the mechanism of how that deficiency came to be. So primary deficiency is primal, right? It's like very rudimentary or basic. So it means that the deficiency occurs simply because a person doesn't consume enough of that nutrient. It's a direct consequence of not taking in enough. It's a direct consequence of undernutrition. Secondary deficiency is not so obvious, right? So the mechanism of action is not so obvious, right? So occurs, how does it occur, right? So secondary deficiency could occur one of three ways. It could be that the person isn't absorbing the nutrient, so they might be eating enough, but for some reason their body isn't absorbing it. A second way is that the deficiency could occur because the person is excreting too much from the body. So it's not being reabsorbed in the kidneys, or somehow, again, it's not being absorbed in the intestines, so it's going out in the feces, or we're sweating too much of it out. So that could be a reason that there's deficiency. Again, they might be eating enough, but they're also excreting either too much or excreting so much and not replenishing enough. And then the third cause of a secondary deficiency could be that the nutrient is not properly utilized by the body. So again, they might be eating enough, they might even be absorbing it, and they're not excreting excess, but for some reason they're just not able to utilize it correctly. So in any of these cases of secondary deficiency, we could still see the disease occur, but the person is also eating enough of that nutrient. So there's something in the middle between eating the nutrient and that indicator of health or nutrient status that needs to be assessed, right? Okay, what are some of the symptoms of deficiency? So again, this isn't, a lot of this isn't specific to nutrition. This is sort of specific to healthcare overall. So again, any of you studying nursing, you're probably learning these same concepts, right? So a subclinical deficiency is kind of the early stages of a deficiency. It's where, so it's subclinical, right? So sub meaning beneath, and the clinical, right? Like a clinical observation, a clinical observation. So if it's subclinical, it's meaning we probably aren't, it's there, but we're not observing it. So subclinical deficiency is in the early stages typically, and it means that few or no symptoms are observed, yet the deficiency is occurring. So we call these symptoms covert, like a covert ops, right? So kind of hidden. So the symptoms are hidden from like plain view and might require lab tests or other invasive procedures to detect. So one of the examples would be iron, like the first stages of iron deficiency. Like typically in the very, very beginning stages of iron deficiency, we can actually store a little bit of iron in our bodies. And so if we start to be deficient in iron, we'll start to use up our stores of iron. And so the person at face value might not be expressing any of the symptoms, yet underneath, if we looked for it, we could see that their stores of iron are starting to decrease. So typically, actually, in the early stages of iron deficiency, there are some symptoms. They're like fatigue, usually, or inability to concentrate so well. But those are kind of subclinical and might go unnoticed. You might just think, oh, maybe I haven't slept well recently, or oh, maybe I've just been so busy. But if we actually looked or did some lab testing, we could see, oh, wait, there is actually a deficiency occurring in the very beginning stages here. And then as the deficiency progresses, the symptoms do become more obvious or overt. So as the deficiency progresses, the symptoms become overt. Symptoms are more obvious and easily identified, like extreme fatigue in the case of iron deficiency. Or you might see, depending on the deficiency, maybe easier bruising, like if you have a vitamin K deficiency and blood isn't clotting so well, maybe bruising easier, and potentially pain, again, is often a symptom that becomes much more obvious. Okay, so let me toggle all the way back to here. So we've talked about assessment, we've talked a little bit about diagnosis, intervention, monitoring, and evaluation. I mean, at this stage in your nutrition journey, I guess we could say, and your understanding of nutrition, well, we haven't really learned nutrition just yet in order for, say, you to write an intervention and then go on with monitoring and evaluation. As we get into, chapter 2 and then chapter 3, 4, 5, we'll really start to be learning about nutrition and nutrition guidelines, and that information helps that information coupled with the assessment is how we would write an intervention for a person. What we're going to talk about next is sources of nutrition information, right? And again, kind of going back to understanding what we know about nutrition. So this section is basically, we'll start to be talking about how do we identify reliable nutrition information? Because once we make a diagnosis and write an intervention for a person, in the nutrition profession, we need to make sure that the advice we're giving is based on sound and known nutrition information. So how do we know that the information we have about nutrition, which informs the advice that we might give to someone else, how do we know that that's actually reliable information? So these next few slides you could utilize probably not just for nutrition, but really you could utilize a lot of this information more broadly now that we're here in the digital age where information is so accessible to most people, right? And that means that there's a lot of misinformation out there too. So how do we sort kind of the junk from what's really actually honest and truthful and reliable? So we're gonna spend a lot of time here. First and foremost, please, for my sake and for your sake, really, like for your integrity, remember that nutrition is an evidence-based science. So if you're going to go out there and start sharing what you're learning from this class, make sure that you can understand where it came from. Not just, my professor at CCC, but like, where is the information that I'm giving you coming from, right? Or if you're going to read something online or in a magazine or in the newspaper, where is that information coming from? And is a magazine a reliable source of information, right? So when we're confronted with claims about nutrition, again, or any other aspect of our world, let's really assess, let's be mindful consumers, right? Let's be mindful humans and consider whether or not there's evidence to support what we're reading. And even if there is evidence, we might even double check the evidence to make sure that the evidence is itself valid, right? So what we're going to talk about in these next few immediate slides is the scientific method. So a lot of times when we talk about evidence, and now I'll kind of refer back to nutrition specifically or any other health discipline, again, whether it's nursing or medicine, the evidence, like even when we were talking about the dietary reference intake values, right? Those values are based on evidence, and that evidence comes from science. And that evidence comes from scientific experiments, basically. So in nutrition, and nutrition again dips pretty intensely into biology and chemistry and mental health and medicine and physiology. So there are many, many different fields and disciplines that are kind of all at the same time studying these various aspects of the science of nutrition and bringing that information all together to help us understand what nutrition is presently. So how is that science performed, right? How are those experiments set up and performed? So there is something called the scientific method, which is actually effectively a set of standards and processes that research, so again, nutrition research or any other research in the health sciences or medicine when the research is performed, these standards and processes have to be utilized. And when the researchers follow these standards and processes, then we can more or less agree and confirm that that information then is valid information and therefore valid evidence. So the scientific method, I think we're going to talk about it in 8 parts. Yeah. So 8 parts to the scientific method. And again, if you're in any other healthcare class or health-related class, maybe you're also learning about the scientific method. Or if you're taking a science class, you might also be learning about the scientific method. So again, this spans a whole bunch of different disciplines. So the steps of the scientific method. First is to make an observation. So like observing that something is going on, right? And you're like, oh, that's an interesting phenomenon. I want to study that and understand it further. So first, kind of identifying something to study. Second is writing a hypothesis, which is basically an educated guess that attempts to explain what's going on. So for example, you might notice that you kind of observe a whole population of people and you observe that seems to be people who eat a lot of fiber maybe are less likely to be overweight, right? So you might say, okay, well, eating adequate amounts of fiber promotes a healthy weight. That could literally be a rough hypothesis, right? Then you would go ahead and design an experiment to test your hypothesis, to test yourself and see, okay, this is what I think is going on. Let me now put it to the test, if you will. Create an experiment to test whether or not what I think is going on is actually the thing that's going on. Then you're going to run your test, collect your data, analyze your data, and see that it either supports or rejects your hypothesis. If the data reject your hypothesis, then you need to write an alternative hypothesis and start again. If the data support your hypothesis, then you might say, okay, these are the conclusions I'm drawing from the information I've gathered. Either way, whether 5 or 6 happens, you're then going to need to repeat the experiment. Or best case scenario, other researchers around the world should be conducting very similar experiments to see if they obtain basically the same results. Ultimately, the scientific method can lead us to the concept of a theory, which is where we've had enough experiments that are the same, that all draw the same conclusion, right? So a theory can emerge from repeated experiments that support the hypothesis over and over and over again. So if we say we read one research study, right, and we read the conclusions of that research study, that's just one research study. In order to actually formulate a theory, ideally we would have, dozens or hundreds of research that looks at the same question and achieves the same conclusion. Here is a kind of pictographic representation of the scientific method, from, again, observation to writing a hypothesis to designing an experiment, collecting your observations and your data, repeating the experiment, again, whether the hypothesis was rejected or supported, and then, if you continue to conclude that the hypothesis was correct through repeated experiments, then you may wind up at theory. So you might pause here and just take a minute to kind of read through this example. Just gives you another example of like something that might be observed and then studied in the scientific method. We'll go through in these next few slides and talk about the type of experiment, because the observation and the hypothesis are pretty straightforward, but there are many different ways that the experiment could be designed. So a few things about the experiment that help ensure that it's a well-designed experiment, which means if it's well-designed, we can probably trust the results, more so than if it's not well-designed. So 3 components of a well-designed experiment. Having a large number of people or animals being tested in the study. So having a large sample size. Sample size refers to the number of people being studied. The more people, the less likely it is that the results you find were actually just due to chance. The second thing, depending on the type of experiment, is that you would have a control group. So you would be looking at 2 different groups. One group, you're kind of not influencing them at all. The other group, you are influencing them based on your hypothesis, but you have that control group to compare back to. So again, control group is actually only relevant in certain types of experiments. And also in these certain type of experiments, you would want to make sure that any other potential variables that could influence the results or the outcome, that those variables are controlled for, meaning if you have 2 groups, you try to make the 2 groups as similar as possible, except for this one thing you're studying. So you might have the 2 groups be all people from the same age group, all people of the same sex, all people of the same ethnic or racial background, all people of the same socioeconomic status, et cetera, and maybe even the same physical activity levels, so that you can really narrow it down to the one thing that it is that you want to be looking at. Again, just reiterating here this idea of the hypothesis and the theory, and that if a hypothesis is really just the beginning, right? And even a theory, like a hypothesis that's supported over and over again kind of advances us to a theory. But even a theory can be challenged or changed as our knowledge and as the evidence increases, right? So as time goes on. But a theory is about as close to accepted fact as we'll ever get, right? So a theory really is a scientific consensus, so a consensus amongst the experts in that field about why something is happening the way it is happening. Alrighty, so the different types of research, let me actually go here because I like this image. So this is picture 1.6 in chapter 1. So we can basically we can kind of organize studies into 3 types: animal studies, epidemiological studies, and experimental trials. Let me just go back to these slides because you can see it a little better, but that image kind of puts all this information together. So animal studies, we do the studies on animals, usually rats or rabbits or mice. So animal studies are typically done to gather preliminary information that would then inform potential future human studies. Typically, we do animal studies when it's determined that the research can't ethically be done on humans, like a nutrient restriction. Like if we know that there's consequences to restricting a nutrient, we deem that unethical to test that on humans, but so far we don't deem it unethical to test it on other animals. So usually it's kind of the dicier experiments that would be done on animals first to try to further our understanding of how that relationship might play out in humans. So some of the drawbacks or limitations of animal studies is that the results might not really apply directly to humans, and there are also ethical implications for doing some of these experiments on animals too. And then in the experiments that we do on humans, we can divide those into 2 groups. So we have epidemiological studies and we have experimental trials. So epidemiologic studies are looking kind of, I like to say like big picture, right? They're kind of looking at everything from kind of a bird's eye view. So epidemiologic studies look at patterns of health and disease in the population being studied, and they indicate relationships between factors, but not cause and effect, right? So oftentimes epidemiological studies are also used as kind of a starting place. Not only, but a lot of times they might be used as a starting place to kind of observe these patterns and these relationships. And then we might design an experimental trial to further understand a specific relationship. So an experimental trial, as that word might imply, is a tightly controlled experiment in which an intervention is given to determine its effects either on a certain disease or a health condition. And it is specifically the experimental trial that's going to have the control group and controlling for the different variables. So again, I said on this slide, when I talked about the control group and controlling for variables, I said that you would want to have two groups, right? Treated and untreated individuals. And so those two groups, if we come back here, are referred to as the experimental group. So this is the treated group. They're receiving the intervention or the treatment. And then the control group, which is not receiving the treatment or the intervention. So they're the ones, the control group is, the kind of the, this is how it is. And the experimental group that receives the proposed treatment, we can compare the effects of the treatment on that group back to the control group that didn't receive any intervention. Again, this slide just summarizes all that, kind of says a lot of the same information. Okay, and then with epidemiological studies, there are also two types of epidemiological studies, or two broader classifications, we could say. So epidemiological studies, we could say that there are observational studies and case control studies. The observational studies, again, observation, right? So just used to assess nutritional habits, disease trends, or other health phenomena of a large population. Again, commonly used to identify relationships, not cause and effect. Cannot determine cause and effect. So case control, still observational, but a little bit of an additional feature. So in a case control, we actually would have two groups in this case as well. So there would be a comparison, but still minimal intervention. So you would compare one group of individuals who has a particular condition and compare them to another group without the condition. So again, no intervention or treatment is given here, but it's a case control. So still just observing, but now looking at kind of two subgroups within a given population and seeing why some phenomenon is occurring in this group and not in this group, right? So again, it's still suggesting just relationship between two factors, not determining cause and effect, but now getting a little bit more specific, because now you can say, okay, well, this is occurring, this relationship occurs in this group, but it's not occurring in this group. So these are two types of epidemiologic studies. Okay, now coming back to experimental trials. So, and actually, I'm going to toggle back again. So when we look at the experimental trials here, some of the more detail that's written here is what's on this slide. So experimental trial, again, this is where you're going to design an actual intervention, and you're going to have your experimental group that receives the intervention and then your control group that doesn't receive the intervention. So some further characteristics of experimental trials that help us understand, okay, that was probably a really good experiment. The results of that experiment are probably reliable information then, probably reliable evidence. So one of the qualities is randomization. And so randomization means that the researchers randomly assign the participants to either the treatment group or the control group, right? So again, if you're looking at a population of people and we said you want to control for all the variables except the one that you want to study, you're going to have this large pool of pretty much the same individuals, or very similar individuals to one another. So randomly assign them to say, okay, basically just go A, B, A, B, A, B, or 1, 2, 1, 2, 1, 2, and then put them into the two groups. One group gets the treatment, the other group doesn't get the treatment, or the control group. So that's a randomization, rather than sort of picking and choosing based on what you might know about the individuals, who's going to get the control, or who's going to get the treatment, and who's going to be in the control group. And then there's something called single blinding and double blinding. So this is referring to the treatment and awareness of the treatment being given. So in single blinding, the participants in the study are not aware whether they're in the treatment group or the control group. So if this is testing for, a vitamin C supplement, or testing for a new pharmaceutical drug, the treatment group would receive the treatment and the control group would receive a placebo. We'll talk about placebo in a second. So it doesn't, whichever group they're in, they're still taking something. So they don't know if it's treatment or if it's placebo. Double blinding is even better in most cases, because in double blinding, neither the participants nor the researchers know who is in which group. So both the participants and the researchers are blind to who's in the control and who's getting the placebo. Or sorry, who's getting the placebo and who's in the treatment group. Maybe I don't have placebo in here. So placebo, if you're not, sorry, I thought I had that out here. But placebo, and this is in your book if you want to see it kind of written out better. But placebo is sort of a lot of times it is actually a sugar pill, but it's usually just a fake treatment, if you will. So sometimes it could even be like in some like psychological experiments, if you're testing a certain type of, like, let's say verbal therapy or a type of some other therapy, the control group might receive a placebo therapy that kind of looks like it's a therapy, but it's not actually the treatment therapy that's being tested, right? And again, in nutrition or in medicine, the placebo might be a sugar pill, where it's something that the participants can take, so they think they're probably receiving some treatment, but it's actually just a sugar pill, and it's not, the medication or the vitamin meant to be studied. So that's what placebo is. It's a sort of fake intervention or a fake treatment that's designed to make the participant think they're receiving the treatment, which allows for that blinding to occur. All right, so that's kind of sums up what we'll talk about, at least in this class, about scientific method. We won't do a whole lot with this going forward, except that for your My Diet Analysis project, I do ask you to provide at least one citation that comes from a reliable or reputable source. So if you choose to use a scientific study in your My Diet Analysis report, you would want to make sure that it is a quality study. We're going to talk through, on the remaining slides, we're going to talk through a few other aspects of how you might identify a reliable source of information, both in the context of scientific research as well as not. So still relating to scientific research here with conflict of interest, but also kind of dipping into other sources of information that you might find. So conflict of interest refers to a situation in which a person or a company is in a position to receive some benefit or advantage from the publication of, or the hiding, I guess, of publicizing scientific results. So conflict of interest means, okay, if these results get published, that might lead to some changes in the population once they read this information, that then turns around and either puts money in the pocket of the people who conducted the research, or some other sort of benefit, right? Or in the same way, if a certain study comes out and certain information is determined from the study, and the researchers say, oh shoot, if we publish that information, that might cause a change in the behavior of people that then stops them from buying some product that we also sell, right? So they might hold that study back from being published. So conflict of interest is a really interesting one to look out for. If it is in the context of a scientific research, somewhere in the published paper, usually either at the beginning or right at the end, conflict of interest does need to be stated. So at least whomever is reading the scientific paper can identify, okay, no conflict, if there was no conflict of interest, they can say, okay, none was disclosed. Or if there is conflict of interest, then the person reading that can see and can be, more informed as to whether or not they want to continue with that information. Some key questions to ask to kind of discern conflict of interest. You might ask who actually funded the study, or who funded the study, who paid for it, who conducted the study, right? A lot of times a company might pay for the study, right? So a large company that sells milk or dairy products might pay for a study to come out that shows that drinking milk is good for you, right? Because then that's going to encourage consumers to drink more milk, which puts money back in the pockets of the milk company. A lot of times, researchers at academic institutions are the ones doing the study, but they might also be involved or affiliated with companies. So again, if they're publishing results that promote the sale of some product, they might get a little kickback for having produced that study. So always asking who did the study, who paid for the study. Looking, again, how was the study funded? Was it funded by a company or a corporation? Or was it funded by the National Institute of Health? And does that company or corporation stand to profit from the results? Did the researchers receive goods, services, or money or other perks from the research sponsor? And do the researchers have investments or ties to companies or products related to the study? So again, oftentimes some of the answers to these questions should be disclosed if there is conflict of interest, and that should be disclosed on the paper itself. But as with all things, sometimes there are little workarounds, and so it might appear as though there is no conflict of interest when actually there might be. So can't hurt to do a little more research and actually look up who it is, who conducted the study, or see if there was any relation to some company or corporation. All right, and then basic internet information, right? So how do we deal with what's out there on the internet? So if you're on an internet page, some key things you could do, right? Check the credentials of either the website sponsor or the person who wrote the article. If you're reading an article, was it written by qualified professionals, right? Was it written by like a writer who's interested in this information, or was it written by a professional in that field? Again, were there financial contributions, and are they named? If it is written by a writer, is there at least an expert reviewer of the content? The website date is another thing you could look for. Is it current? Is it something that is subject to change over time? If it is, then you want the date to be current. If it's something that probably wouldn't change over time, then probably an older date is okay. And then also .com. Remember that .com is .commerce, right? So .com is usually a for-profit site, whereas .gov, .edu, or .org usually are for educational purposes or public services. So usually .gov, .edu, or .org would be more reliable than a .com. Again, other questions you might ask, so who's reporting the information, right? Is it based on reputable research? Are they referring to a scientific study, but they don't link to it, right? If they're going to refer to a scientific study, they should link to the study. Is the report based on testimonial, or is it based on fact, right? And always, I think this is always a good one, are these claims too good to be true? If it seems too good to be true, do a little digging and see what's behind there. There's this concept of quackery, which is basically the promotion of unproven products or services, usually by unlicensed or untrained individuals, usually for financial gain. So there's a lot of quackery going on the internet these days. Alrighty, and then in terms of, if I go back to here, qualified professionals, so what are some titles or designations we might look for to find a nutrition expert? So you might look for a registered dietitian or nutritionist, which might look like RD at the end of the name, or like a licensed or certified dietitian or nutritionist. A lot of times, or now, there is a different certification that can be achieved, which is a certified nutrition specialist. So someone can become a certified dietitian nutritionist by having received the certified nutrition specialist credential, so you could look for that one. Otherwise, maybe they haven't received that licensing or registration, but they might have a pretty good professional degree. So they might have a master's of arts or sciences or a PhD. You'd want to see that it's related, though, to nutrition or medicine, or they might be a doctor or a physician. The term nutritionist has no federal, so like national regulation. The legal definition is done at the state level. So like in New York State, you can be a registered or certified dietitianist or certified nutritionist. If they don't use the term certified nutritionist or registered dietitian, they may have some of these studies behind them, like they may have done the certified nutrition specialist credential, or they might have a master's degree or a PhD. But interestingly, just the term nutritionist, anybody can use that term, is what I'm trying to say. And it's really only if they are a certified nutritionist or if they have some of these other credentials that you could trust, that you could denote that person as a more trustworthy source of information. But if they're just calling themselves a nutritionist, there isn't a whole lot of regulation around that specific term. So look for some of these other credentials, is what I'm trying to say. And then some government sources of information, and we will use these and reference these. So there's the Centers for Disease Control and Prevention, the CDC. There's the National Institutes for Health, the NIH. They fund a lot of research studies. And then the NHANES, so the National Health and Nutrition Examination Survey, is a really large-scale study that is often referenced when we're talking about nutrition and medicine. So it's a very reliable source of information, as well as the Behavioral Risk Factor Surveillance System. So these are all actually websites that you could go to and learn more about the information that's been gathered from different studies. Again, these are two studies themselves, the two in the middle. NIH supports and funds studies, and then the CDC is basically one of our public health domains that helps relay this information to the public. And then lastly, some other reliable organizations that you could refer to. So again, any of these would be great sources if you were looking to cite something for your My Diet Analysis project. So the Academy of Nutrition and Dietetics, the American Society for Nutrition Sciences, the Society for Nutrition Education, the American College of Sports Medicine, and Physicians Committee for Responsible Medicine. This is just a short list, but again, any of these professional organizations, if you go to their website and you're citing an article that they wrote, or they might link to a scientific study, these would all be great sources of information for you to learn more about nutrition and also to cite as a reliable source of information, whether for this class or some other class. Okay, so that's it for the content of the lecture. All of the lectures that I have are going to end with some, maybe 5 to 10 slides of like Q&A. So these are just little chapter review questions. I'm not going to talk through them or say anything, but I will just like move the slide forward so that you can pause it, try to answer the question, see the answer. If you have any questions about, if you go through these and you get really stuck on one and you're like, well, why is it that answer? Definitely feel free to email me about that. I'm happy to help you kind of talk through and figure out, why it is the answer that's given and not something else. Alrighty, so I'll say here, thanks for joining, thanks for watching the Chapter 1 lectures, and we will see you next time for Chapter 2. And then I'll play through these slides until the end. And so again, just pause as you want to think through and answer the question.